media, it's hard to place the spotlight on science when the front pages tend to be concerned more with politics or celebrities. However, on July 4, 2012, scientists at CERN, the European Organization for Nuclear Research, had announced that they had discovered what could possibly be the Higgs Boson, otherwise known as the God particle. Well, okay, not that kind of God. This discovery quickly made news headlines, appearing everywhere from the New York Times to National Geographic. Even though the world was not entirely sure at the time if what the scientists at CERN had discovered was truly the Higgs boson, the possibility put the world into a physics craze. Tons of articles online and videos on YouTube started popping up, trying to explain what exactly the Higgs boson is. Why was this discovery so significant? It definitely had to mean something if it had the nickname God particle. And again, not that kind of God. The Higgs boson particle, part of the Higgs field, is widely accepted as the thing that gives other particles mass. In order to better understand the Higgs boson, especially without getting too complicated with matters such as quantum mechanics, we must also better understand forces and fields in order to simplify what the Higgs boson is. Electromagnetism is a force, just like gravity and nuclear forces, which allows particles to interact in a certain way. For example, a chair doesn't fall through the floor because electromagnetism keeps electrons from pushing against each other. The forces that exist actually come from virtual particles that tend to snap in and out of existence. A field is then not a continuous and large invisible particle allowing force, but rather a distribution of these virtual particles. Thus, the density of the particles determines the strength of the field. An example of this is how these particles tend to be dense when close to the ends of a magnet, then disperse when further away. As these virtual particles snap in and out of existence, it is difficult to observe them in the same way that we study normal matter. In fact, trying to observe it in the same way we do for normal matter could be a violation of the conservation of energy, that things can't just snap into existence. Scientists then realized that the best way to even get a glimpse at virtual particles was through coaxing them into existence. This is what the scientists at CERN did. CERN had been able to build huge machines that could conduct just enough energy to coax these virtual particles into existence. Now, a while ago I said that the Higgs boson is something that helps mass exist. But how does one even know where to find the Higgs boson? Mass exists everywhere. We are taught that everything has mass. And what is the Higgs field? The Higgs field, similar to the electromagnetic field, is the even distribution of Higgs boson particles, 4 square particles for mass. As it is believed that an object would be the same mass anywhere in the universe, it is similarly believed that the Higgs field is everywhere. However, some particles don't have mass, such as a photon. Consequently, physicists have agreed that the Higgs field gives certain particles mass, as some interact with the field while others don't. In order to better understand how the Higgs boson gives particles mass, you kind of have to think of mass as a force. It's a little difficult at first, but it becomes easy to understand the Higgs theory once you do. Okay, so mass is a force. Compare the Higgs field and mass to the magnetic field and magnetism. It's a similar deal, except unlike a magnetic field in which the particles come out from a particular point, the Higgs field is evenly distributed everywhere. Magnetic objects, such as a paperclip, can interact with the magnetic field, and thus are attracted to a magnet. Non-magnetic objects, such as paper, cannot interact with the field, and thus do not get attracted to magnets. Similarly, particles in mass, such as a tree, can interact with the Higgs field, giving them mass. Particles that don't have mass, such as a photon, cannot interact with the Higgs field, which is why they don't have mass. This is why the discovery of the Higgs boson holds so much importance in the scientific community. It gives us the reason why particles have mass. It gives us the source of a fundamental element of physics. Even though after the initial discovery, CERN could not completely confirm that the virtual particles they saw were actually the Higgs boson. However, Peter Higgs and Francois Englert won the Nobel Prize in Physics for their work the following year, which is why the Higgs boson has been named after the physicist Peter Higgs. However, in 2014, it was confirmed that those particles were actually the Higgs boson. So what does this mean for the scientific community? This means that scientists can better understand mass. And with enough time, it could be possible for us to even manipulate mass through the Higgs field. Additionally, mass existing through the Higgs boson was initially just a theory, but now with this discovery, scientists can now come up with laws to better understand mass to complement the theory, such as a certain amount of interaction with the Higgs field will result in a specific mass of an object. Once again, the significance of the Higgs boson is that it's not just a theory truly confirmed, but a new way of understanding the world around us better. Thank you.